For decades, we have been told a simple rule: 8 hours of sleep per night. It appears in health magazines, workplace wellness campaigns, and even clinical recommendations. Yet from a neuroscientific perspective, this number is not a biological constant. It is a statistical average. Human sleep is regulated by two interacting systems, the circadian rhythm and the homeostatic sleep drive. The circadian rhythm, governed by the suprachiasmatic nucleus in the hypothalamus, coordinates physiological processes across roughly 24 hours. Meanwhile, the homeostatic system tracks how long we have been awake, building sleep pressure through the accumulation of adenosine in the brain. Together, these systems shape not only when we feel sleepy, but how deeply we sleep and how restorative that sleep becomes.
Welcome to Sci Curious ID, where curiosity meets science.
Sleep itself unfolds in structured cycles. Each cycle lasts approximately 90 minutes and includes non-rapid eye movement stages, culminating in slow-wave sleep, followed by rapid eye movement sleep, or REM. Over a typical night, most adults complete between 4 and 6 cycles. This means that total sleep duration naturally ranges between roughly 6 and 9 hours. What matters biologically is not merely the number of hours, but the number and integrity of these cycles. If one individual completes 5 full cycles in 7.5 hours, they may awaken refreshed. Another individual may require 6 cycles, closer to 9 hours, to achieve comparable cognitive recovery. Genetics further complicates the picture. Research on familial natural short sleepers has identified mutations in genes such as December 2nd that allow certain individuals to function optimally on around 6 hours of sleep without measurable cognitive impairment. These individuals are rare, but they demonstrate that sleep need is biologically variable. Conversely, some individuals are genetically predisposed to require longer sleep durations. Chronotype also plays a role. Early chronotypes, often called larks, experience melatonin release earlier in the evening. Late chronotypes, or owls, exhibit delayed melatonin onset. Forcing a late chronotype into an early schedule may result in lighter, fragmented sleep, even if the total time in bed equals 8 hours. Age introduces another layer of variation. Adolescents often require 8 to 10 hours due to developmental changes in brain plasticity and hormonal regulation. Adults typically require 7 to 9 hours, though this range is broad. In older adults, total sleep time may decrease slightly, but slow-wave sleep often declines more significantly. As deep sleep diminishes, subjective restoration may change, even if total sleep duration appears sufficient. Sleep quality is therefore as critical as sleep quantity. Deep slow-wave sleep supports memory consolidation through hippocampal cortical communication. It also regulates growth hormone release and contributes to metabolic and immune balance. REM sleep, in contrast, is associated with emotional processing, synaptic recalibration, and procedural learning. Two individuals may both report 8 hours in bed. However, if one experiences frequent micro-awakenings or reduced slow-wave sleep due to stress, noise, or circadian misalignment, the restorative value differs substantially. Lifestyle factors dynamically modify sleep need. Physical training increases slow-wave sleep demand. Cognitive strain elevates recovery requirements. Illness and inflammation increase sleep pressure. As part of immune regulation, even travel across time zones can temporarily alter sleep architecture, as the circadian system attempts to resynchronize. Importantly, sleep need is not fixed across a lifetime. It fluctuates with physiological demand. From a neuroscience perspective, the more meaningful metric is functional outcome. Do you awaken spontaneously without an alarm? Do you feel alert within 30 minutes? Can you sustain attention across the day without excessive reliance on caffeine? Is your mood stable and your reaction time consistent? If these indicators are stable, your sleep duration is likely aligned with your biological requirement, whether that is 7 hours, 8 hours, or slightly more. The 8-hour recommendation emerged historically as a public health guideline designed for population-level simplicity. It serves as a useful baseline, but it does not capture individual neurobiological diversity. In empirical terms, optimal sleep duration is the amount required to maintain cognitive clarity, emotional regulation, metabolic stability, and immune resilience. For some, that is precisely 8 hours. For others, it is not. The key insight is this: sleep is a biological process governed by genetics, circadian timing, age, and physiological demand. A single universal number cannot fully account for that complexity. So rather than asking, "Am I getting 8 hours?" perhaps the more scientifically meaningful question is, are you getting the amount of sleep your brain actually needs? And how would you know if you weren't?
Thanks for watching SciCurious ID. Until next time.